Hi students. In this lecture, I am going to discuss total internal reflection. Let us see what is it. Let us consider a light ray traveling from, let us take, this is now boundary separating two media, and light ray travels from denser to rarer medium. This is now normal at the point of incidence. Light ray travels from denser to rarer medium, instant ray, and this is angle of incidence. And when light ray travels from, this is now denser medium D, and this is now rarer medium. So this is the mu of the rarer medium, and this is now mu of the denser medium. Now it bends away from north. It is now like this, and this is now angle of refraction. Okay. Now see Snell's law. Mu denser sin I, that is equal to mu rarer sin R. Now observe carefully. Mu denser, mu rarer, both are constants, these two. If angle of incidence is increased, angle of refraction also increases. And here one more condition is that R is greater than I. See carefully. Since light ray entering into rarer medium, it bends away from normal. That means R is greater than I. One condition. Now I value keep on increased. When I value is increased, R also increases. And condition is R greater than I. Let us take for one value of I, R becomes 90. See the meaning of 90. It becomes 90 means light ray grazes the surface. So grazing means it is not touching the boundary. So here what we are doing is, if angle of incidence is increased, angle of refraction also increases. Since R greater than I, first R becomes 90, right? So the angle of incidence for which angle of refraction is 90, that is called critical angle. So we are taking as a C. C stands for critical angle. It is known as critical angle. So it is the angle of incidence in denser medium for which a refracted ray touches the surface or grazing the surface, or we can say angle of refraction is 90. Then see what happens. Mu denser sin C is equal to mu rarer sin 90. Okay. So from this we can write sin C equal to mu rarer by mu denser. Right. Next. Now see what happens when R becomes 90. If we increase angle of incidence further, then see what happens. R value cannot be greater than 90. From this diagram, we can say what is the maximum value of angle of refraction? It is 90. So beyond 90, it is not possible. See, what is the meaning of that? It is not possible means refraction is not possible. See once again, sin I equal to mu r sin r. The angle of incidence for which angle of refraction becomes 90. That is known as critical angle. Now, we are still increasing the angle of incidence. If we still increase, R value cannot be greater than 90. That means here refraction not possible because we cannot take here Snell's law, right? That means there is only reflection. So you can see here when angle of incidence is greater than C, when I greater than C, light ray reflects completely. In the sense, there is no refraction. Means light is not entering into other medium. That is what we can say from this relation. So R value maximum 90. Still, beyond that, if we increase angle of incidence, there is no refraction. That means only reflection takes place. This is known as total internal reflection. So one condition is light ray should travel from denser to rarer medium. See carefully once if you take reverse, like traveling from rarer to denser medium, mu rarer sin I is equal to mu denser sin R. When we have relation like this, that means if light ray travels from rarer to denser medium, I will be greater than R. That means in this, R value cannot become 90, right? Because when I value is 90, its meaning is light ray instance parallel to surface. In such a case, no refraction. Okay, that means angle of refraction can become 90 only if light ray travels from denser to rarer medium. Okay, if angle of instance greater than critical angle, or if it is slightly greater than C, light completely reflects, no refraction at all. This is known as total internal reflection. Okay. Generally, what happens is whenever light falls on the boundary, always having reflection and refraction, both will be there simultaneously. This is, let us take it as R, or let us take R dash, angle of reflection, and this is now angle of refraction R. Whenever light falls on a boundary, some of the light energy enters into other medium. That means refracts. So having a reflection and refraction always. But here, when light travels from denser to rarer medium and angle of incidence greater than critical angle, there is only reflection, no refraction. Means when we compare these two cases, what makes difference means always having reflection and refraction. But in this case, only reflection. That's why it is named as total internal reflection. So to have this, it has to satisfy two conditions. Light must travel from denser to rarer medium. Second, angle of incidence should be greater than critical angle. Okay, let us make now what is angle of deviation in this case. Let us draw here angle of deviation. Let us take this is now deviation. delta, and this is now angle of incidence. Let us see how this deviation depends on angle of incidence. So just now we have seen here up to some angle of incidence having both reflection and refraction, right? Now we are focusing first of all refraction. So what can be the maximum value of R? That is 90. Okay. So in this case, deviation will be R minus I because R is greater than I. When R becomes maximum, deviation becomes max. That is 90 R value. For this, a corresponding angle of incidence is critical angle. This is the maximum deviation during refraction. Okay. And once I value greater than C, it is only reflection. And when you are taking only reflection, then deviation will be pi minus 2y. Okay. So we are having it here two parts. Up to C, this is relation. Beyond C, pi minus 2y. Means up to C, it is a, this is curve is not a straight one, but after C, the curve becomes a straight line. Let us see. It is a curve up to, let us take this is now critical angle. For critical angle, deviation will be pi by 2 minus pi by 2 minus. And if angle of incidence is slightly greater than I, slightly, so immediately it becomes now reflection. So I'm taking here somewhere here. There's a corresponding angle of deviation. It is a pi minus 2c, right? Because pi minus 2i, we are taking now angle of incidence is slightly greater than c, slightly. So it becomes pi minus 2c. And as I value is increased, deviation gradually decreases. Then see how graph is now. It is a straight line. This is now graph. It is a straight line having negative slope. Okay. And this becomes 0 when I value is 90. You can see here, if I equal to 90 means 2 into pi by 2, then deviation becomes 0. See what is meaning of 90? Its meaning is that light ray incidence parallel to surface, right? Angle 90 means light ray incidence parallel to surface. Then no reflection, no no reflection and no refraction. That's why no deviation. Okay. So this part is for refraction. During refraction, maximum deviation pi by 2 minus c. So here we are taking light ray travels from denser to rarer medium. Okay. Next, slightly greater than c. It is reflection. Right. Okay. Let us take now graph for deviation. If light travels from rarer to denser medium, reverse case. See how the graph is. So taking light ray travels from rarer to denser medium. We want to plot a graph for deviation as a function of angle of incidence. See, when you are taking from rare to denser medium, first of all, see Snell's law. Right. If light ray travels rare to denser medium, this is rarer and this is dense. Angle of incidence and angle of refraction. This is R. So in this case, angle of incidence is greater than R, right? So deviation will be I minus R. Now see the graph. Let us take Snell's law. Mu1, that is mu R sin I, that is equal to mu denser sin R. Mu denser sin R. So we want to find out R value in terms of phi. That means this is written as I minus, see in the place of phi. What we can write? Sine inverse mu denser by mu rarer. Wait, we want to find R, right? Okay. Mu rarer by mu denser, mu rarer upon mu denser, sine I. Okay. So we want to plot a graph for deviation as a function of angle of incidence. So see the graph now. Right. You can see this deviation will be approximately like this. This is deviation and this is angle of incidence. And you can see what is the upper limit for deviation. Upper limit. See maximum value. If you take I value is 90. Okay. I value is 90. This is 90 means pi by 2. And this becomes 1. That means this maximum deviation delta m, that delta m will be equal to pi by 2. In the place of pi by 2 minus sine 90 is 1. Remaining is now sine inverse mu rarer upon mu mu rarer upon mu denser. See carefully once. What is the meaning of it is I value is 90. I value is now slightly less than 90. Then only having a refraction. Okay. Because if you take exactly 90, no refraction. Slightly. So this is now 90. Okay. So this is the deviation versus angle of incidence when light ray travels from a rare to denser medium. So this is not exactly 90 because when it is exactly 90, no refraction and no reflection. Okay. So here we have taken deviation only because of refraction. And this is now for slightly less than 90. Okay. Let us see once till now what we have discussed, the theory points. Light should travel from denser to rarer medium. Angle of incidence should be greater than critical angle. And what's the meaning of critical angle? It is the angle of incidence in denser medium for which angle of refraction is 90. That means light ray grazes the boundary. Okay. Let us now solve problems basing on this. See the first one. A ray of light traveling in a transparent medium falls on a surface separating the medium from air at an angle of incidence 45. The ray undergoes total internal reflection if n is the refractive index of the medium with respect to air. Select the possible values of n from the following. So asked for 2 marks in 1998, given angle of incidence 45, and this undergoes total internal reflection. So we have to choose possible values of n and see carefully n is refractive index of the medium with respect to air, and we are taking for air refractive index is 1. Therefore, see carefully here, traveling from denser to rarer medium, denser and rarer. This is 0. Okay. So you can take mu r, that is equal to 1, and this is mu. So mu of the medium with respect to air, that is mu by 1, right? It is mu only. Okay. Given I value 45. Since it is now total internal reflection, we can write I is greater than C, right? Condition 1. Given I value 45. So 45 should be greater than C. Now take sign on both sides. Sin 45 greater than sin C. Okay. And we got sin C value. Sin C value mu rarer by mu denser. Now in this case, it is air. So 1. And this is now mu, which we have to calculate. That means 1 by root 2 should be greater than 1 by mu. See from this what we can write, mu greater than root 2 means any value that is greater than root 2 is possible. Okay. See options. So root 2 means 1.414, right? So any value greater than 1.414 is possible. This is less than 1.414. This also less than 1.414. This is greater than 1.414. This also. Therefore, among the given values, the possible values are 1.5 and 1.6. Right? Let us see next one. A ray of light from a denser medium strikes a rarer medium at an angle of incidence psi. The reflected and refracted rays make an angle of 90 with each other. The angles of reflection and refraction are R and R dash. So reflection R, refraction R dash. Okay. The critical angle is, okay. So conditions are given. So here what we have to keep in mind, angle of reflection is R, refraction is R dash. Okay. Given for 1 mark in 1983. Let us see how to start it. So first note down the given data, boundary. You can see angle of incidence, angle of reflection, that is R. Okay. Next, angle of refraction. This is r dash. So condition given that r plus r dash is 90. This is one condition given. And we are knowing that angle of incidence is equal to angle of reflection. I equal to what? This is known. And this is a given condition. So we have to find critical angle. Okay. So this is now mu denser and this is now mu rarer. Then we can write Snell's law. Mu denser sin I should be equal to mu rarer sin r dash. And see what's the value of c. We are knowing that sin c equal to mu rarer by mu denser. That means we have to find sine inverse mu rarer by mu denser, right? Now see from here what we can do. Mu denser in the place of 5, what we can write? In the place of 5, we can write it is r. It is sine r, right? Mu r in the place of r dash. In the place of r dash, we can write 90 minus r. 90 minus r. Sine 90 minus r. Okay. In the place of r dash. So from this, see what we get. Mu denser sine r is equal to mu rarer cos r. R from this sin r by cos r tan r. Tan r equal to mu rarer by mu denser. And this is nothing but sin c, right? Nothing but sin c. That means what is c value? So c equal to sine inverse tan r, right? So just we have taken the given condition r plus r dash equal to 90. And this is known. And we have to find c value. Sin c equal to mu r by mu denser, right? So just taking Snell's law and from that making the calculation part. Okay. So I hope you got the clarity. So answer is sin inverse tan r. So it is option A, right? Sin inverse tan r. Okay.